Hi, calculus students. Ms. Deer back on the mic with you today, and we have been talking about infinite series. So remember that we defined an infinite series. It's a sum from n equals 1 to infinity of a sequence. So remember, we're adding the terms of a sequence and producing a series of finite sums. We can start at 1 or we can start at 0. And either one of these is called an infinite series. So we talked about two special kinds of series. The sum from n equals 0 to infinity of a times r to the n. This converges when the absolute value of r is less than 1. So when r is between -1 and 1. It diverges when the absolute value of r is greater than 1. We also talked about a telescoping series. So this is something where the terms are going to cancel out when you actually write out the terms. And I will tell you now that these are the only two series that we are actually going to find the sum of the series. So let's go ahead and work through some examples. So if I want to take the sum from n equals 0 to infinity of 3 over 2 to the n. Now this is day one and we haven't seen a lot of series, so we know it's either going to be geometric or telescoping. We can see this is geometric. You can actually rewrite it as the sum from 0 to infinity of 3 times 1/2 to the n, which might help you to see that a equals 3 and r equals 1/2. Because r is 1/2 is between -1 and 1, we know this converges. And we know that this converges to the sum a over 1 minus r, which in this case is 3 over 1 minus 1/2, which is 3 divided by 1/2, which is 6. Working through another one here, let's say I have the sum from n equals 0 to infinity of, let's do 3 over 2 to the n. Well, this is again geometric. A is 1. R is 3/2. Well, because r is 3/2, that's bigger than 1. So because this is bigger than 1, we know this diverges. So let's look at a little tougher one here. Let's take the sum from n equals 1 to infinity of 3 over, we've seen 2. Let's do -2 to the n. So again, this is geometric. And we know that a equals 3. We know that r equals -1/2. And it's going to converge because -1/2 is between -1 and 1. Between -1 and 1. But what do you notice here? We don't have a 0 term. And our formula, a over 1 minus r, only works when our sum goes from 0 to infinity. So I have two choices here. I can either rewrite this, right? So if I want to rewrite this, remember that if n equals 0, then this is 1. So when n equals 0, it's giving us the first term of our series. So if I were to look at the first term of this series, I can see that my first term, if I plug in 1, is -3/2. So if I were to start this series at 0 to infinity, it's going to be a. So a is -3/2. Now r is what we're multiplying each time. -1/2 times -1/2 times -1/2. So this stays. And now I have a geometric series starting at 0. R is between -1 and 1. So this is going to converge to a over 1 minus r. So this is -3/2. Dividing by 3/2 is same as multiplying by 2/3, and I get -1. So the other kind of series we've looked at is telescoping. So an example of a telescoping series is if I say start the sum from n equals 2 to infinity of 1 over n plus 1 minus 1 over n minus 1. Now this index is important because I'm going to start at 2. So the first term of this series is going to be 1 over 3 minus 1 over 1 plus. This is when n equals 2. So then my next term is going to be n equals 3. And if I plug n equals 3 in, I get 1/4 minus 1/2. Now my next term is going to be n equals 4, which is going to be 1 over 5 minus 1 over 3. Plus, now if I do n equals 5, I get 1 over 6 minus 1 over 4. We'll do one more here. N equals 6. I get 1 over 7 minus 1 over 5. So hopefully you can start to see here that what is going to cancel out is my 1/3 are going to cancel out. My 4ths are going to cancel out. My 5ths are going to cancel out. My 6ths are going to cancel out, right? Everything is going to cancel out. What am I left with? This is never going to cancel, and this is never going to cancel. So it's going to converge to -1 minus 1/2, which is -3/2. Right, because you can see that my next term right here, right, is going to be, I have 5, 6, 7. I'm going to have 8 minus 6, so my 6s are going to cancel, my 7s are going to cancel. And that's going to just go ahead and play on down the line. So we've seen two special series. We've seen converging or telescoping series and geometric series. The last thing I wanted to talk to you about here is probably our best tool, and this is going to be called our nth term test. And what this says, this comes in two pieces. So our first part says that if the sum from n equals 1 to infinity of an converges. If the sum converges, then eventually our end game is we have to be adding 0. So then the limit as n approaches infinity of an has to be 0. Remember, as our terms get bigger and bigger and bigger, we have to be adding less and less and less for the sum to approach a finite value. So, how can we use this? Well, then it's also true that if the limit as n approaches infinity of an is not 0, then the sum from n equals 1 to infinity of an diverges. So, if my sum converges, then the limit is 0. If my limit is not 0, then my sum diverges. But if my limit is 0, then maybe it diverges, maybe it doesn't. This is only a test for divergence. This is my, I don't know, big star. So I'm going to give you a minute to write this down. Again, this is only a test for divergence. This only can tell us right away that a series diverges. If my limit is 0, then it's back to the drawing boards. So how can we use this? Well, let's say I have the sum from n equals 1 to infinity of 3n plus 1 over 2n minus 1. It's not geometric. It's not telescoping. But we can quickly see that the limit as n approaches infinity of 3n plus 1 over 2n minus 1 is 3/2. So when n gets really, really, really big, we're essentially adding plus 3/2, plus 3/2, plus 3/2, plus 3/2. And so this sum is going to diverge. It's going to diverge because it fails the nth term test. Right away we can see that because the limit of the terms is not 0, there is no chance that this series can possibly converge. So let's do one more. Let's look at the sum from n equals 1 to infinity of 2 over n. So again, it's definitely not a geometric series. It's not telescoping. And I can see that the limit as n approaches infinity of 2 over n is 0. So what do we know? We know that you're going to have to come back to class because we don't know if the series converges or diverges. All we've shown is that it doesn't immediately diverge. So the last one, if we take the sum from n equals 1 to infinity of n plus 1 over n squared plus 4. Oh, I might want to factor that, but it's a sum of two squares, and that's not going to work. But I can see that the limit as n approaches infinity of n over n, well, n plus 1 over n squared plus 4 is 0. Again, this one is 0, so tells us nothing. So hopefully this has piqued your interest. We have a lot more fun with sequences and series yet to come.